Okay, so we were discussing about the expressions and operators. So how do we construct expressions, executable expressions? So data is stored in variables which are named according to some convenient uh, names so that you can identify individually different variables, and the transformation of that information happens through operators, and there are so many several operators that are available, fundamental operators. And then depending on what are the operands, what is the type of operand, those operators actually behave accordingly. And in such situations where the behavior of operator is different according to the nature of the operands, this behavior is called overloading, right? So the output is dependent on what kind of input you have. To put this in context, a division operator is overloaded. The results are different depending on whether you are computing 3 by 5 as integers, 3 as an integer, denominator 5 as an integer, and if you divide 3 by 5, integer division would result in 0, right? The result would of course be integer. But if you divide 3.0 by 5.0, the result would be 0.6, right? The operator is same, but the behavior depends on what is the nature of the operands that it is operating on. And this kind of functionality where the uh, behavior of the operator changes, this is called overloading. The same symbol is capable of performing different tasks depending on what arguments it is operating on, right? And this overloading is a very useful feature which is used extensively in C++, right? And particularly with object-oriented programming, when we develop methods for to deal with the data in classes. And operators have all predefined precedence using usual rules of arithmetic. So different operators have different precedence. I mean, anything that is enclosed in braces, parentheses, takes precedence, that has the highest priority. Then multiplication, division, or remainder operator, they have same precedence next in order. And if there are combination of multiplication, division, and remainder operators, then the execution happens from left to right. Whichever operator comes first as you traverse from left to right, that operation is performed, right? And then the last precedence is for addition and subtraction, again from left to right. And if you wish to override these natural precedence orders, then of course you need to make use of parentheses. And if you are not sure, it is always a good practice to make extensive use of parentheses so that there is no confusion. You know exactly what you want to do and you implement it exactly. The computer will implement it exactly what needs to be done, right? So use of parentheses is uh, highly recommended. And just to show you the examples, expression 2 plus 5, 2 plus 3 by 5, right? So if you move from left to right, right, division has higher precedence than addition. So 3 by 5 will be evaluated first, and then the result would be added to the addition operator, right? So in this case, 3 by 5 is of course 0, and then the result is added to 2, and the result of course remains 2. But if you use parentheses, if you wish to add the two numbers first, 2 plus 3 divided by 5, then the result is going to be 1. 2 plus 3 will add up to 5, then 5 divided by 5 is equal to 1. So this is a source of error. I mean, if you are not careful about how the precedence will work, then it's a this is a source of very serious trouble later on, because it will compile, program will compile, there is no error here, and it will compute whatever it needs to compute according to the order of precedence order, right? And you would never figure out, or it will be very very difficult to figure out where things are going wrong, right? In this case, the numbers, you can see the numbers and you can figure out what is happening. But when you write the code, instead of numbers, you have variables. Let's say x1, x2 divided by z1, right? You have no idea what is x1, what is x2, what is z1, and where things are going and how things are being performed, right? Unless you print out those values. So it is always a good programming habit to use parentheses, even if the result would be computed correctly according to the precedence orders. Default precedence order. Never harms to use parentheses extensively, just to remove the confusion. Make it explicitly clear this operation needs to be performed first, this operation needs to be performed next, and so on. Right? So to alter the default sequence of operations, we can write the operations as 2 plus 3 within parentheses and then execute the division. And the result is of course much different from what we had earlier. Then we have two important stream operators, that is stream insertion operator when you try to uh, feed into output stream, and then you have stream extraction operator when you try to uh, extract the data from input stream, right? So these are two basic operators, and extensively used for input output, for interacting with the system, and also from reading from file or whichever input and output device you decide to choose. And both these operators are again overloaded. It knows, I mean, if you try to write hello world, that is a string, I mean sequence of characters. If you try to display numbers, whether integer or float or double, doesn't matter, it will faithfully display all those numbers correctly according to the appropriate syntax, right? So that is possible because these operators have been overloaded. Depending on what data is coming in, appropriate version of this operator is used, right? And the programmer is of course completely oblivious of what is going on, right? It doesn't matter. It is transparent to the programmer, it is transparent to the user. The compiler provides these facilities to use whichever operator is exactly which version of this operator is to be used depending on what data is being dealt with, right? Then we use assignment operator. It's called assignment operator. It is not equality sign, right? Equality sign is assignment operator in all programming languages, right? So when I say x equals 5, it does not mean x equals 5. That is actually the post facto. What it means that whatever is on the right hand side of that operator, R value, it is called R value, it is assigned to the left hand side, whatever appears on the left hand side. So that is L value, right? So R value is assigned to the L value, left value, right? So 5 is assigned to X, identifier X, right? And after it is assigned, then of course it becomes equal, right? So it's a slightly semantic difference, but in the end, it does mean equality, right? So as in this example, standard deviation is identified, is declared as a float type identifier, float type data, and it is initialized to have zero value, right? So that is the assignment, and you assign zero value. So standard deviation, once it is declared, it contains that particular storage would be interpreted as float data representing zero. So example of a valid arithmetic expression from the code grading.cpp. Well, this is the code that I use for computation of grades in a course, students' grades. Right? Obviously, it's based on statistics, calculation of the statistics, relative performance of the students, and so on. So cutoff of A plus is average plus 2 times standard deviation. Right? That is the any score above this cutoff level will be uh, assigned A plus grade. Right? So whatever is the class average that goes in this identifier av, right? And then I add 2 times standard deviation. So this is the continuation mark that I was referring to the other day. So I continue the execution. There is not enough space here to store, to write this identifier completely. So I just use one backward slash and then continue writing the expression as if the entire expression was being continued on this single line, right? Compiler would just replace this forward slash with whatever it finds in the next continuing line, right? So this number, this identifier contains certain number that would be the class average score of the entire class, and then to the average we will add twice the standard deviation. So this becomes one number, and that is assigned to this cutoff A plus. So this is another identifier, right? So this is, so backward slash is a line continuation operator, and all identifiers should be declared first before they can be used in expression. C++ is very strict in type checking, and that is a good thing. It may sound a little bit of irritating at first uh, because you need to declare everything, you need that increases your typing effort, etc., right? But that is a very good safety mechanism. Otherwise the results, code can produce results in very uh, unpredictable manner, right? But C++ provides this functionality, this additional flexibility which is not there in C. Identifiers can be declared anywhere you want to use them. So if I wish to use this cutoff A plus here for the first time, I can just declare cutoff here and then initialize it with this value straight away. So I could have said, I mean, if this cutoff A plus was not declared earlier, I could have simply said float cutoff A plus, and this is assigned this value of average plus 2 times standard deviation, right? That would be perfectly fine. So the philosophy is, as far as possible, use local variables with limited lifespan, right? So scoping rules, we discussed about the lifespan of identifiers. So try to declare variables or identifiers whose lifespan is limited. They do not linger on for too long in the program, right? So declare it, use it, discard it. And discard, this process of discarding happens automatically. If I declare a variable within a for loop, outside that for loop, that variable doesn't exist, right? So that way you can actually choose and limit the visibility of variables at different points in the code, and that allows you to make use of the same identifiers again and again with different context. Not necessarily a very good programming practice, but that is a feature that you may sometime find handy, right? So identifiers can be declared anywhere in the code as long as it is done before their use in the expression, right? So when the expression is being executed, it needs to know what type of data it is, what type of data, because everything depends on the type of data. Operator, which operator is to be used, that depends on the type of data. If you don't know what type of data it is, which operator is which version of the operator is going to be used. So type definition is very necessary. Without that, compiler would not allow you to go ahead. I mean, it would just trigger error and stop at that point. So this is a great flexibility. I mean, you can virtually invent variables as you go along. I mean, you are writing a code, suddenly you find that you need some kind of storage space to store some result. You can straight away declare a variable and use it right away and get on with it. So that's a great flexibility. You don't have to look at the top of the file where you have declared all the variables, right? So the possibility to declare variables anywhere in the code is a great possibility, but it can also be a source of error, because now there is no designated place to look for identifiers. I mean, your identifiers, definition of identifiers can be anywhere in the code. So in C, there is identifiers can be either global identifiers, that is before the main, and either, or I mean just next to, I mean the first few lines of the main function, right? That is the only two places where identifiers will be declared or defined, right? So you can readily go and find out what those identifiers are. But once you have this flexibility that you can define identifiers, variables anywhere as and when you like, then there is no designated space. So they are virtually scattered all over the code, right? So it becomes little difficult to track at times, and that may, if you are not careful enough in nomenclature, that may cause conflict sometimes. You may inadvertently be overwriting contents of an identifier which was not intended. So this possible conflict is resolved by the scope of the identifiers, and that is why this feature, that lifespan is limited. If it is declared within a for loop, then outside that for loop, that identifier is no longer available. So if you need that identifier, you need to declare it again in that scope. Now, as I said, there are essentially three things that you need to solve a problem. One is your decision making, and decision making is essentially testing out different conditions. Second one is repetition structure, and third one is the logical execution. I mean, flow of instruction, right? Flow of instruction is provided by the language standard. It will start from the master program, master function, that is main, and then step by step it will start executing the statements. So decision making is essentially uh, evaluating true or false. So you can test various conditions. One is equality operator, whether if x is equal to y. So these are two equal signs. So that is equality operator. Single equal sign is actually assignment, and that will always, almost always, return a true value after assignment, right? Conflict will happen only when you try to assign incompatible data type to incompatible identifier, right? So if you try to assign a float variable, float data to a character variable identifier, then you are going to have a problem. So that assignment would fail, right? And this next one is the closest you can get to that not equal to sign using the typewriter keys, right? Exclamation and equal. That is the closest you can get to that not equal to sign. Not equal to sign, if you recall, is right. So this is approximated by this, right? So this is as close as you can get, and there is, I guess, there is no source of confusion here. So these are two equality operators. Either two variables are equal to each other or they are not equal to each other. So you are testing those two conditions. Again, it does not make sense to test the equality of two float type data, right? That would almost always be in error because of the round of errors. Even if theoretically two numbers are supposed to be equal, it's extremely remote possibility that both those numbers would be computed to be equal. They may be computed to be close enough numbers, but exactly identical numbers computation is a remote possibility, right? So you should always, if you want to compare equality between two numbers, it is better to test, convert it into inequality. Let us say the difference between two numbers, if it is less than whatever is the acceptable tolerance. How close is close enough? You define that tolerance, and if the difference between two numbers is less than that tolerance, for all practical purposes, you have achieved equality, and then you can write your code accordingly. But equality does make sense for comparison between integers or characters, right? So it's not that equality is a useless operator. It does make sense in certain contexts, but certainly not in the context of real numbers or float or double type numbers. So those are better served by relational operators. That is, if you compare whether one number is greater than the other number, or whether one number is smaller than the other number, or whether one number is greater than or equal to the other number, or less than or equal to other number, right? So those are four relational operators. Then you can combine these various operators using logical operators. So you have AND operator, you have logical OR operator, or you have logical NOT operator, right? And you can build up different logical sequences, decisions based on these operators. So then there are arithmetic operators. You can have simple addition, subtraction, multiplication, division, remainder, etc. But then there are also increment operators, decrement operators, right? So plus equal is is synonymous with replacing or modifying the contents of a variable by addition or incrementing it by some value, right? So x plus equal dx is essentially x plus dx. This number is computed and assigned to x. So that's only, I would say, shorthand. I am not a great fan of these kind of shorthand notations, but the standard defines it, so you should know. It really, it uh, baffles me. Why would anybody like to sacrifice this clarity for this weird structure? This is so much more readable, so much more clear what you are trying to do, right? But such is life. People do not like simple things, right? This is, to me, it looks more like gimmick. That's all. Then there are increment operators. You can prefix it. So before you use the value of identifier x, its value is increased by 1, and post increment is value is increased after you have used the identify whatever is the content of x, right? So plus plus x. So essentially x plus 1 is replaces x, right? In both the cases. Decrement is subtract 1. So 1 is subtracted from the identifier either before the use of identifier or subsequent to the use of identifier in the expression. So pre-decrement and post-decrement. Again, this is again a source of confusion. If you are not very sure, it is better to stick to nice and clean x equal to x plus 1 and then write whatever statement you want to write, right? Doesn't hurt to type one extra line. At least syntax is very clear. So only 3 control structures are needed to write a computer program. So any computer, you can solve any problem by using 3 features. You only need 3 features. One is sequence or flow of instruction. You should know, computer should know how to execute instructions in what order. So that sequence is natural. It comes from top to bottom, right? So starts from master code, main, first line of that master code, and then sequentially it goes one after the other, right? So that flow of instruction is natural. It is built into the code, so you don't have to worry about it. Second one is the selection structure, the branch, which branch to take. So branching out, decision making, right? So there are 3 types available. Conditional evaluation. So if something, some condition tested, if that condition is true, then do this. And if that condition is not true, then you have if else. So you have 2 branches. One If statement only executes that statement only if certain condition is satisfied. Otherwise, it moves on to the next sentence, next statement, right? Otherwise, if you have a branching out, then there is an else clause. If this is true, do this, otherwise do this, and then move on with the rest of the code. And then there is a switch statement. There are multiple instances, and you can choose appropriate branch to. So instead of if else only gives you two branches, switch gives you option of several branches, right? It's not that you cannot use uh, if else or only if to achieve multiple branches. You can very well do. So just one decision structure can also serve the purpose. But again, it is a variety, different flavors, whichever flavor you prefer, you choose that flavor. That's all. It's like saying I like butterscotch more than vanilla, right? Then you have repetition structure. Some set of statements need to be repeated again and again for a certain amount of time or up to whatever number you specify, right? So again, there are uh, three repetition structures that are available in C++, that is while, for, and then do while, right? The difference is between while and for, it is syntax is slightly different, but they are more or less same thing. Do while is different from these in the sense that the contents of the code in that do and while between this will be executed at least once. The condition is tested only at the end, right? So one run through that loop is guaranteed. For loop, while loop, that depends on the condition, right? That loop may be entered, may not be entered. But do while, you will execute it at least once. So how do you, I mean, this is the basic building blocks of a code. Using these three features, you can solve any problem. You can write any, you can write a working program using these. So how exactly do you go about developing a code? Different programming styles have their own way of designing the structure of a code. It is never, whatever programming style you prefer, it is never a good idea, no matter how tempting it might be or how strong the urge might be, to go and start typing the code right at the your IDE, integrated program development environment, code environment, code blocks or Visual Studio or whatever. You should always work out this strategy, think through what the program needs to do, where does the data come from, how that data is to be stored, to be analyzed, and what output needs to be produced and how that needs to be displayed or stored or whatever, right? So only after you have given a careful thought, then write down what we call as pseudocode. Those are just rough sketch statements, the simple sequential logical statements of what needs to be done in order to solve the problem that you need to solve, that you have been given. What does it need? I mean, how will you go about solving that problem, starting from the input data? So go by logical steps that you would take to solve that problem, write it down, and that will give you pseudocode. translating pseudocode into an algorithm is, I mean, once you write the pseudocode, you will realize that it translates into a working algorithm of how you need to develop your program to solve that problem very, very easily, right? So once you write down that logical sequence of steps, then you will find that you almost have the structure of the code in front of you. All that you need to do is translate it in the using the grammar of the particular language that you want to use. So if it is C++, use the grammar of C++. If it is Fortran, use the grammar of Fortran, or whatever. Right? So this is a typical example of the sequence of steps in a solution. So pseudocode for calculation of a student's grade in a course. So what are the, I mean, basic input, total number of students enrolled in this course. Then read and store individual scores. What are the individual scores? Then you need to compute the average of that score. So you add it up and then divide it by the total number of students. That gives you the average. Then you need to compute the standard deviation, knowing the average and individual scores. Find out what is the standard deviation. And then depending on your different thresholds, you need to compute the grade thresholds. What is the cutoff value for those grade thresholds? And then once you find the thresholds, then you just go over the individual scores and look at which bracket that particular score falls in and assign the appropriate grade accordingly. That's the complete set of operations, right? So we'll stop here. That's the time I have. Any questions?